Students, in this video lecture, we'll study about model 3, that is transformer. I will give you some idea about the transformer and what is the need of this transformer, then why this transformer is essential in this scenario. Then what is the need of necessity of transformers, we'll study about it. See, especially for the power grid, transformers are essential for power transmission over long distances. So usually the power which is generated at the generator, it must be transformed at the consumer end. So the generated energy must be transmitted through the transformer. Transformers are essential in that level. So the generated power is efficiently sent through the need wherever the consumers are there, where we are going to transform. So this process will be done by the transformer. Usually the high current low voltage AC power is generated at the generated end, which is stepped up with the step up transformer into the high voltage low current. So usually around 220 kilovolts or more voltage is generated. So then again this voltage is transmitted through transmission line. At the receiving end, that particular voltage is again stepped down using the step down transformer. So this will be done by the transformer. This is the whole necessity of the transformer. Usually in the power grid, these are the most essential things of the power system. What is the low current key? Usually the practical wire size, whatever we use in a overhead line, it will reduce the wire loss because of the high overhead line, high voltage, whatever we use, it reduces the wire loss and it reduces the cost also. Usually the transformers are also used in electronics, where the small transformers are used for the mixing purpose, coupling purpose, impedance matching purpose. There also we find the necessity of the transformer. Then with this background, now we'll study what is the transformer. So usually the electrical power transformer is one of the static device where the electrical energy from one circuit to another circuit it will transform without any direct electrical connection, and with the help of mutual induction principle between the two windings, the electrical energy is transmitted from one electrical circuit to the other circuit. It transfers the power from one circuit to another circuit without changing its frequency. That is the most important part. The frequency remains same, but the voltage level will change. So from step up transformer, low voltage to high voltage, then in the step down transformer, high voltage to low voltage, the voltage level will change, but the frequency remains same. Let us go with the principle of principal operation of the transformer. Usually the transformer, it depends on the Faraday's laws of electromagnetic induction. Usually the mutual induction principle is used, so that mutual induction between the two windings is responsible for the transformation action which is taking in case of electrical transformer. So this would be clearly shown in the next figure. Before that, we will study the basic concept of the transformer, how the transformer will work. Usually what happens, the alternating current is applied to one of the electric coil. As you apply the electric current to the first coil, the flux will be surrounding the first coil. This, if we bring another coil near to the first coil, then the alternating flux linkage will be taking place in second coil also, using the mutual induction principle. This flux is alternating, so there will be a rate of change of flux linkages with respect to time that takes place in the second coil. So the Faraday's laws of electromagnetic induction, using that the EMF will be induced in the secondary coil. That will be shown here. This is a primary coil, first coil. The voltage is applied across this. So small current will produce the flux. This is the dotted lines are the flux. Using there is no medium here. Air is the medium. So through the mutual induction principle, the flux will be generated in the secondary coil also, second coil also. Whenever the second coil is bring near the first coil, using mutual induction principle, the flux will be created at the secondary coil also. This is the induced voltage, what we call. This is called as the flux. So this is the alternating force. This is first coil. This is the second coil. This is more clearly shown in this particular part. This is called as the primary winding. This is core of the transformer. This is secondary winding. This is primary winding. So this is the flux, leakage flux only through the first primary coil. This is the flux which is given to the secondary coil also, linking the secondary coil also. So this is called as the main flux. So this is the flux which is created only due to the secondary winding. Let us glance about the construction of the transformer. Usually the transformer consists of main primary winding, the secondary winding, and the core part. This is the magnetic core part, which is produced by the flux, as I discussed right now. So usually the magnetic flux will be produced in the primary coil. This is connected to the secondary coil. This is the main heart of the circuit, that is the core. This will link the primary to secondary coil. This is the secondary coil what we are showing in the figure. Magnetic core of the transformer, about that I will discuss. Transformer core is constructed by using some sheets, like these are the laminated sheets that is shown in the figure, where in between these sheets the minimum gap is created. Usually the steel is used with a high silicon content. Silicon steel is used, where it is heat treated to provide the high permeability and low hysteresis loss. These laminated sheets are used to reduce basically to reduce the eddy current loss. This is the shape of the sheets what we are seeing here and here. These sheets are of E shape, I shape, L shape, to avoid the high reluctant at the joints. These sheets are highly laminated and stacked or arranged in a particular fashion, so that this will become the perfect core. So these are the I end, this is the E end. These are the laminations are stacked together. This will become the core of the transformer. Let us glance what is the type of the transformers we have. So broadly the transformers are classified based on the construction. This is core type and shell type. Based on the purpose, what purpose we are using, the step-up transformer, step-down transformer. Based on the type of supply, that is, one is single phase transformer, another one is the three-phase transformer. Then based on the use, we are using that is classified as power transformer, distribution transformer, and instrument transformer. Based on the cooling whatever we employed, we classify it as oil filled self cooled type transformer, oil filled water cooled type transformer, and air blast type or air cooled type transformer. This is the broad classification of the transformer. Based on these all criteria, we are classifying the transformer. Okay, based on one criteria as for construction, purpose, type of supply, and the use and the cooling, the transformers are classified as shown in the table. Let us glance what we mean by core type and what we mean by shell type. As the name itself suggests, here windings are in cylindrical form, or mounted on the core limbs. The cylindrical coils of the different layers are insulated each other. The paper or mica is used for the insulation purpose. Usually the low voltage windings are placed nearer to the core, as they are easy to insulate. The shell type are again mounted on layers, stacked insulations. A shell type transformer is a simple rectangular form. It is in rectangular form, as shown in the figure. This is the shell type. This is rectangular form. This is a core, and this is a shell type. Magnetic flux is linked here. This is the core type of transformer. Here coils are windings are wound here. Primary and secondary coils are here on the limbs. Here it is a shell type. Here middle layer will come. The another picture of that is shown here. The low voltage insulation nearer to the core. Okay, you can see that low voltage insulations are nearer to the core. High voltage insulations are outside. Okay, So this is the shell type and this is the core type transformer as far as this is considered. This is the some categories or classification of the core type and shell type transformer is given. Usually in core type of transformer, core has only one magnetic circuit. The core cross section is uniform, as it is shown. The core has one magnetic circuit and it is having the uniform. And core has two limbs. You see, it has two limbs. It has two limbs. And magnetic flux is uniform at all the sections of the core. You can see here magnetic flux is uniform at all the sections of the core. And the coils are placed on two limbs. Usually these are the limbs, these are the coils. These are the coils. The coils are placed on the two limbs. The winding surrounds considerable part of the core. Better cooling since more area is provided, cooling is there. Natural cooling is also provided. Easy access to the windings to make the maintenance. Mechanical protection of the coil is less as compared to shell type. In case of shell type, here two paths for the flux in the core. The cross section is central leg is provided here. You can see here. The coils are on the central limb. Okay, the coils are here, but the coils are at the outer limb. Okay, the core has three limbs as shown here. It is one limb, two limbs, three limbs. Okay, three limbs as shown here. Three limbs are for the shell type. Central limb carry the double flux compared to outer limbs. Coils are placed in the central limb as I shown here. Core surrounds the winding. The cooling is less because as the coil is inside in the central limb, cooling is less as compared to shell type. It is difficult to provide the natural cooling as in core type. Less access to the winding makes maintenance difficult. So here what happens, if anything happens to the windings, that can be easily repaired, or maintenance is very easy in case of core type. Here maintenance becomes very difficult as coils are inside. That is the problem. So mechanical protection to the coil is more, as coils are inside. So mechanical protection is more as compared to core, but here coils are outside. Mechanical protection is less as compared to the shell type. So this is what I am wanted to cover in this video lecture. In the next video lecture, next part of the transformer will be covered in the next video lecture.